Okay, more of the practice problems for the Chapter 2 test, and we always have these sketches on here. We've got to identify our limits. I kind of want to work this out so you can see as we do it. We'll just go through the logic. All right, let's bring this down here just a little bit. There we go. All right, so first question, the limit, this is my function. It's a piecewise function. It's got all these little discontinuities in here. Okay, the limit as x approaches 2 from the left, so I don't have to look at positive 2. And as I approach 2 from the left, what's that limit going to be? Looks like as I approach 2 from the left, it looks like that's going to be the vertical position. It looks like it's going down, down, down to -1. That should be okay, so it's just -1. That makes sense. And the limit as I approach 2 from the positive direction. So that was from the left. This is from the positive direction, and I'm going up like this as I approach 2. As my x value approaches 2 from the positive direction, it looks like I'm approaching 3. That's 2 from the positive direction, so that would be 3. And the limit as I approach 2, well, as I approach it from the left, it's -1. As I approach it from the right, it's 3. So since the left-hand limit does not equal the right-hand limit, that limit does not exist. Okay. And what is f of 2? Do I have an actual value for a function? Because I have an open here and an open circle there. But at 2, I do have a value. The value of the function is just exactly 2. Okay, let's take a look at -4. So -4 is over here. The limit as I approach -4 from the left. -4 from the left. It looks like it's going up to infinity. So we could say the limit equals, we could say infinity or does not exist, or infinity, which kind of describes the behavior. Hope that's all right. Okay, let's see what happens when x approaches 1. I'm sorry, -1. -1 from the positive direction. So as I approach -1 from the positive direction, it looks like my height is approaching 1. So that's okay. And as I approach -1, well, that's better enough. Just to add, what's the limit as I approach -1? Well, as I approach -1 from the positive direction, I get 1. As I approach -1 from the negative direction, I also have 1. So since the left limit equals the right limit, the limit is also equal to 1. Okay. We didn't ask what the left-hand limit was, but it's going to have to be 1 for that limit to exist. And what's the limit of f of x as x approaches 0.5? Well, 0.5 here is right here. Well, it looks like as x approaches 0.5, it's right in the middle here, right? It looks like my limit's going to be 0 because it's right in the middle. So that's okay. All right, and then number 16, use the graph of f of x, the above graph, and identify the types of discontinuities that occur at the given points. So when x equals -4, what do we have? Well, is it removable? No, I can't fix it with a point. Is it jump? No, in order for it to be jump, we have to see both endpoints. I don't see both endpoints because it goes way up here, so it's infinite. So that's an infinite discontinuity. When x is -1, when x is -1, looks like I can just fix that with a point if I fill a point in there. All right, the left limit equals the right limit, so the limit exists. And I can fill it in with just a point, so this is what we call removable. Because I can fix it by, I can remove it by adding a point, just one point. And at 2, well, if we look at 2, we have a big old skip here, and that's what we call a jump discontinuity because it's jumping from -1 all the way up to 3. So that'd be a jump discontinuity. Okay? So that's pretty much how you would handle those kinds of problems. I hope that helps.